Hi, this is one of 6 recordings for Chapter 14, in which I will be performing a lab question from Chapter 14 in order to test a null hypothesis about the average between two different neighborhoods' ages being equal versus being different. So we can call this the case problem to demonstrate the use of STATCRUNCH in testing hypotheses about differences between the two means. So the first thing that I will do is share screen with you and open a problem. In this problem, a developer wants to know if houses in two different neighborhoods were built at roughly the same time or not. So the developer takes a random sample of 6 houses from each neighborhood and finds their ages from local records. And there's a table, and this table is presented to you in the problem. This is problem 3 of 24 problems available in lab work for Chapter 14. And as you can see, the data table here shows you the 6 home ages of the 6 neighborhood homes, followed by the averages, variances, standard deviations, as well as the difference between the two means and the standard error for the composite standard error in this question. Now, as we read the problem, one other thing you notice is that the problem directs you to test the null hypothesis that the average age of houses in two neighborhoods is the same. So in this case, the null hypothesis is that there is no difference in the mean age between one house and another. So mean 1 minus mean 2 equals 0. That's the null hypothesis. The alternative hypothesis will be very similar. The alternative hypothesis will be that such a difference is actually different than 0. This is what we call a two-tailed hypothesis test in earlier chapters. And what we're going to do in order to test the hypothesis is look for a very important assumption, which is what kind of analysis of variance should we apply? And it says here that we're to assume that the data come from a normal population that is normally distributed. So these are two different neighborhoods. The data come from relatively normal populations, and the homes are going to be treated as if the neighborhoods are independent of one another. So not only are the samples, but also the neighborhoods are independent. And as such, what we're going to do in order to create the hypothesis test is going to StatCrunch and follow the stat menu into tstats with two samples and follow the command sequence therein. So first, let me take you back to this particular problem. And what we're going to do is open this data in StatCrunch. Upon opening the data in StatCrunch, let me show you where the data are and share that window with you. So we're going to go into Stat, tstats, to sample with data. And we're going to select neighborhood 1 and neighborhood 2 as the 2 columns of data. And we're going to just test the hypothesis of the difference being 0 versus not. So it's already pre-selected. We click on compute, And we learned that the average age difference in the neighborhoods is 6 years, give or take 4. That the degrees of freedom computation is 9.2 degrees of freedom in this T statistic, and that the test statistic is 1.424, meaning that there's a difference of 1.4 standard deviations between the null hypothesis of 0 years difference, and the observed data difference of 6 years of difference. So when we go back to the problem, what we put here is the test statistic, 1.424. So the degrees of freedom computation, which is very messy, as you can see, because you're basically taking the weighted average of the degrees of freedom between the first sample of 6 and the second sample of 6 being combined together into a total variation, gives you a degrees of freedom of 9.2. Now, I didn't do the math on this myself. I relied on the arithmetics between I relied on the arithmetics from STATCRUNCH. So let me show you where this degrees of freedom computation came from. It's right there. It's right next to the T statistic. It's to the left of the test statistic. Now, if we are looking for a different formula for the degrees of freedom, we would have used 5. 5 is the minimum between 6 and 6, because there are 6 observations in every data set. You may recall that that there are 6 observations in every data set. So if we use a different rule, the rule of the minimum between the degrees of freedom of the sample size 1 and the sample size 2, you'll notice that in both cases, this rule would have yielded 6 minus 1, which is 5 in both cases. And when we then find the p-value using the degrees of freedom from part B with 9.2 degrees of freedom, the p-value is the one given by StatCrunch in the calculated test box. So this p-value here of 0.1872 is the relevant probability that the null hypothesis may be reasonably true. That 0 is the actual difference in age between the houses in neighborhood 1 and the average of the houses in neighborhood 2. So I'm going to go back to the problem and simply put in the calculated p-value using StatCrunch. And if I use the p-value using the degrees of freedom from part C, what I would have to do is I would have to go back to StatCrunch and use the T calculator with 5 degrees of freedom. And I would have selected the two-tail hypothesis, where I employ the test statistic calculation of 1.424, negative and positive, giving me a confidence level of 0.7862 for an interval around 0, and allowing these 2 white areas of doubt in the null hypothesis to be the complement of that computation. In other words, to be 0.2138, the complement of 0.7862, which is the whatever is left in these white areas here. And those white areas would have a p-value then of 0.2138. Since both of those values are much higher than a reasonable doubt criteria of 5%, which is what the level of significance of the hypothesis test is, we would fail to reject the null hypothesis, and we would say that there's not enough evidence to reject the theory that the homes in these 2 neighborhoods are of different ages. And we would say that we are fairly confident, we're about 78 to 80% confident that these homes average just about the same age for the two neighborhoods. So this concludes this example demonstrating how to calculate all statistics in StatCrunch for hypothesis tests about the difference between two population means. I thank you for watching, and I hope that you use this video productively to help you complete this highly valued 94-point assignment. Take care.